Hello everyone. In this video, we're going to be looking at a cubic function and its inverse. F of x equals x cubed plus 3x, and we're trying to find the inverse of this function. Now, does this cubic function have an inverse? As you should probably know, when you graph a cubic function, it's going to curve, and usually we'll have a maximum and a minimum, so something that looks like this. And it doesn't always have more than one real solution, but that doesn't matter. It's gonna twist and turn, making it a not one-to-one function, right? So, do you think there's gonna be an inverse for this function? Let's go ahead and find out. All right, great. So we have f of x equals x cubed plus 3x. To find the inverse of a function, most of the time, we do actually set the expression f of x equal to y, and our goal is to turn this relationship from x to y to x. In other words, switch the roles. And to be able to do that, we're basically going to be looking at an equation. And the equation that we have right now is actually a cubic equation. So in order to look for an inverse, we are actually going through the cubic formula. So this is also going to be a good practice for the cubic formula. But the question is, a cubic equation has more than one solution. So does this mean this function has more than one inverse? For example, if you consider the graph that we just talked about, depending on these intervals, you can kind of split up our cubic function into 3 pieces and then look for an inverse on each interval, right? Is that what we're going to do? Let's go ahead and find out together. So I'm going to start by setting this equal to y, and that gives me the following. This basically, like I said earlier, this equation is going to be a cubic equation. Now let's go ahead and remember the identity we use with a plus b cubed. If you subtract from it 3ab times a plus b, you get a cubed plus b cubed. I hope you will remember this identity because it's something that I use very often for factoring problems and similar problems, but also for the cubic formula. Great. Now, here's what we're going to do. We're going to go ahead and call this x so that we get a cubic equation from here too. So x cubed minus 3abx equals a cubed plus b cubed. So in other words, we basically produced a very similar cubic equation. And here we can actually play with the values of a and b to get the equation we want. So how do we get this equation in particular? That's going to be very easy. Just by comparing the coefficients, we do need that negative 3ab equals a 3 and a cubed plus b cubed equals a y. For right now, just treat y as a constant and x is the variable, okay? Because this is cubic in x, meaning that y is supposed to be a constant. All right, great. So this is our system. Let's simplify this a little bit. This means ab is equal to negative 1. And what we can do is we can actually cube both sides and write this as a cubed b cubed, and that's still going to be negative 1. And now we got this equation and that equation. So that gives us a good system. How do we solve it? By substitution, right? How do you substitute? Let's go ahead and replace b cubed with y minus a cubed. We can take this and replace the b cubed with that. Let's do it and see what happens. A cubed multiplied by y minus a cubed, which is b cubed, equals negative 1. I'm going to go ahead and distribute everything and then put everything on the other side and simplify this. Let me go ahead and write this as y a cubed minus a to the 6 equals negative 1. Let's put everything on the right hand side. A to the 6 minus y a to the third minus 1 equals 0. Even though this looks like a hexic equation, maybe a little hectic, it actually can be turned into a quadratic by calling a cubed something. How about a cubed equals c? All right, you see what I'm talking about? Now replace a cubed with c. This is going to be c squared minus yc minus 1 equals 0. Notice that we started off with a cubic. Obviously, it was a depressed cubic, by the way, which made things a little easier. and then we turned it into a quadratic, which is nice because we were able to reduce the degree. That's the goal. You can do something similar with quartics, but you can't do anything like that with quintics. Quintics are a whole different ball game. And that's why we have a formula or theorem called the impossibility theorem. Anyways, that's a long story. We can probably talk about later. But this is my quadratic equation, and let's go ahead and solve it. And what else can you use besides the quadratic formula, right? So with the quadratic formula, c becomes y, the opposite of negative y, plus minus the square root of y squared minus 4 times negative 1. That's going to be a plus 4. There you go. And divided by 2a, which is the coefficient of c squared, which is 1. So now this is my c. But there are two values. And that makes sense because c is a cubed, but a and b are interchangeable. Look at that. They're added, they're multiplied, obviously. So we can do the following. Set this equal to a cubed, but at the same time it's b cubed. So we're going to get two values from here for a. And you can just treat one as a and one as b. Makes sense? I hope it does, because a and b are basically the roots of this equation. Anyways, let's find out. To find a from here, we're basically going to be cube rooting this expression. So suppose a becomes this and b becomes that. And again, if you switch them around, nothing is going to change because their sum is still going to be the same. Okay? Awesome. So that's a, that's b, and x, is that what we were trying to solve for? No, y. And y is, actually, no, not really y. We're solving for x in terms of y. Here we go. So x is a plus b. Great. So since x can be written as a plus b, it's just going to be the sum of the cube root of these two things. And guess what this does? Were you able to guess that? Okay. We're so close to the end, but hang in there because I still need to show you something super duper cool. Now let's go ahead and get rid of the a plus b. I just want to write this equal to x, and guess what? This actually gave us the inverse function, but x in terms of y. In other words, if y is equal to f of x, x is equal to f inverse of y because they change roles. But then if you want to write this as f inverse of x, all you have to do is replace the y with x and forget about the previous x. Just replace it and you're going to get the following function, which seems to be the inverse of our cubic. But does this actually work? Because another thing is, like I said earlier, there will be 3 solutions, and a really nice challenge would be try to find the other roots from this one. Okay, that's going to be your exercise. Please let me know how that goes. But let's go ahead and take a look at something real cool before we finish. And that is going to be, ta-da, on Desmos, I graphed these two functions. The original one and its inverse. Notice that how they're symmetrical with respect to y equals x. And yes, these functions are actually inverses. And this brings us to the end of this video. Well, thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.